Hey guys, welcome back. I'm just going to cover a fun lecture about understanding how easy it is to compromise applications that are hosted in a Kubernetes cluster. If obviously you know what you're doing and if you have some understanding of the Kubernetes architecture. Uh, the fact of the matter is now that people have moved to DevOps, Kubernetes is becoming one of the platform of choice for developers as code-centric workloads like containers or serverless are taking over the application, and thus understanding how to secure your application in this type of environment is becoming critical. And as we'll show you, hacking your way into a Kubernetes cluster to try to get unauthorized access is not as difficult. Now, this is really tied as well to the shift left security discussion, which is focusing on securing your code, on securing your container images, because essentially applications are pods, and pods are container images that are deployed within them to host applications, right? So if you have a compromised container image, or if your user is downloading the container images from the Docker Hub or open registries, and these have been compromised, have been poisoned, either at the container image layer or the code of the application that has been checked in by the developers in the repository in the CI/CD pipeline. That whole chain needs to be secure. So where the attacks coming from vulnerabilities or from malicious files like malware. Could be ransomware, could be crypto mining, and so forth. But the easiest one that you really want to deploy is in your application is having backdoors, and we see that with Solarity. Because once you have a backdoor, then you can trigger that backdoor without having any permission, without having any credentials, because applications are exposed to the internet. You just curl your way in, or just have an API call, and you can trigger and thus the exploit or trigger the backdoor, and then weaponize your application, in this case in Kubernetes. All right, so without further delay, let's just get moving. Now, I spoke of exploits. That's what CVEs are. They're essentially exploits can be done by leveraging uh, vulnerabilities that are uh, you know that are impacting code, whether it's in the container images or in the code itself of the application. So in this particular case, if someone wants to get access to unauthorized access or access to a Kubernetes cluster of an enterprise, for example, he needs to find some way to get somebody's credential or the credential and use them for his own account. So for Kubernetes, it's going to be either a human user credentials or a service account credentials. If it's human user, it's going to be a TLS certificate, a TLS key that has been obviously validated by the cluster. If it's service account, all you need to get is the JSON web token, okay, and that's it, which is a bearer token type authentication. Now, the extra premium is that token has privileges, which is permissions, hopefully root permissions. Then the attacker will have hidden jackpot and could use that either to uh, you know compromise your cluster, do damage, steal data, and so forth, or use that for lateral attacks, or just for recon, whatever. So the particular vulnerability that I'll be using is CV6271 that was discovered in 2014, also known as shell shock or the bash door or the bash bug. Essentially, it's a bash vulnerability, and bash is used across Linux all over, right? So in this particular case, it affects all systems, like Linux or container images, doesn't matter, Kubernetes, but it's essentially running into web servers like Apache. Okay, so you use Apache to publish web pages, and if the Apache that has not patched this particular CVE, then somebody could use this CVE shell shock to trigger to execute commands, and those commands could be to steal data, to steal your credentials, and so forth, um, or to execute any arbitrary commands. So this in turn will allow you to get what you want, is getting the a token, a JSON web token that pods use to authenticate themselves with the cluster itself, i.e. the API server. All right, so that's basically the bash block. Now you're going to tell me what are the odds for me to get a bash block? What the odds are just for a developer to use a container image that is vulnerable to the bash block because it was not patched, and the fact that you don't have any security scanners, or that either didn't detect or detected, or there's just too many CVEs in the list that the security team did not bother to patch, and that's it. I mean, or some user downloading the web server Kubernetes manifest, which is the configuration file from the internet, because you say, hey, I'm just going to download the web server manifest so I can deploy it, because most of the time users don't know how to configure Kubernetes or create resources. So they will go and get the manifest. And this is not something corner case, right? You want to install a CNI, your network plugin, you download a manifest from the web, and I'll show you. So if you want to have, if you want to install WeaveNet, which is a CNI, which is the network interface, you just download this. It'll say copy paste and do it. Now, how many people will go and look at the actual manifest and what's in it? No one. Well, as a security team, yes, you should. But this typically is a combination of service accounts with permissions, rules, roles, or cluster roles, and bind it to the service account, as well with services to expose the pods that are running in daemon sets or deployments and so forth. Whether it's a security, even security tools, applications, web servers, this is how it works now. So this is nothing out of the ordinary. What the dangerous part is, if you don't have security, if you don't have proper security at all layers in your cluster, then you're going to have a problem. Okay, so what I've done is essentially created a manifest to deploy the web server. So if you have a look at what it is essentially a deployment. The deployment is deploying the pods in two replicas that are using a certain service account. Obviously, this is where me, attacker, is publishing a web server with a service account that has root privileges, and that's basically here. So the service account is what I say here, and the role that I'm giving it is cluster admin role. So this, as long as you know how to configure this, anybody could do this, right? But the problem is if you're a user or developer that is not a cluster admin, and you look at this, this will be like a Martian, basically. It won't make any difference. Okay, so, and that's the risk. Okay, and using a web server image that is that has the bash CVEs that is not patched. Okay, it's one of my containers. I built one because I used the Apache 2, and I just added the bash with the reliability. Okay, so what we're going to do is we're just going to deploy this to deploy the app. Okay, so let me just do a quick thing. I need to change the container image when I'm looking at this. So I've called the container image, just for the sake of this exercise, I've called it bombshell. Just to make a point. So the image is bombshell, which essentially is an Apache server. It's publishing a CGI build webpage. Bombshell. All right, it's on Docker Hub. Okay. All right, so how do you do that? Well, you do kubectl create. That's what the user would do. Why is that? And this will install service account role bindings, because that's what's needed for an application to run. Now, if you don't have a service account, it picks up a default service account, which is great, and you could steal that, but that doesn't have any permission to allow you to do anything, so there's no point. So the best is to publish an application on some internet site and put the link to download the manifest, and the user will just go in and download that. And that's basically the best way to deploy a compromised application on an enterprise cluster. And the security team will not know about this, right? Unless the container image that is being used to run the application is scanned with a scanner, a container image scanner, or unless the registry that is hosted, that the only users only to download the image from, is locked down and secure and scanned at all time, and so forth. So unless you have this multiple layered security in your environment, this you're going to have to deal with this kind of issues. So now we have a service that is, let's say you want to expose a deployment, so you want to have a service for a fixed IP address, node port, so you can access it from the internet. This service had the endpoints, which are the pods hosting the Apache web servers. There's two. So if I was to do a curl of the website, be 85 slash CGI bin slash bombshell. So I called my bombshell. Obviously, if I'm a real attacker, I'm calling it something else. I'll call it my Apache or something else, something that is not threatening, and it'll be just some web page. In this case, it's shellshocker.net. It's just a bash script, essentially. Now, so as you can see, this is a valid web server running a valid web page, but that is running as a valid, safe application in your cluster until somebody will weaponize it by taking advantage of the exploit. Okay. So how do you take advantage of exploit is by executing a command with the curl as part of the curl. Okay. So to do that is, so what do I, before I go there, so let me, so what are we looking for? We're looking for the service account token that I've made the users to deploy so they can deploy the server. So service accounts automatically gets token generated depending on the permissions you've set with the roles, and then mounted as a volume, as a secrets volume in the pod itself hosting the application. And it's stored at a specific location. So if I was to get pods, right, the location is well known. I mean, it's on every documentation. You don't have to need to be a Kubernetes expert. But I guess if you're not studying Kubernetes, you wouldn't know about it. And the location, as you can see here, the token is a secret type. That's typically how you want to do it, and it's mounted at this particular location, so it's not a secret. It's on the pod file system, and the pod file system at the var secret Kubernetes service account token. Okay, so if I was to, just to show you guys, if I was to do a exec, so I'm gonna basically log into the pod itself and access that from the pod file system. Bash, sorry, just use bash, and I'll just do cd var. So I'm inside of the pod now, and cd var run secrets Kubernetes. And I'm just going to shorten up a bit. Service account, and if I do ls, that way, not only you can basically get the token, you can get the namespace, but all you need is a token, and you have also the certificate authority as well of your Kubernetes cluster. You know, you don't have the key, but you have the CA. So this pretty the CRT. Okay. Now, if I was to do cat token, voila, this is the bearer token I can use to authenticate myself anonymously. Well, not anonymously. If I use a token, I'll be kind of assuming this identity, and with having cluster admin level permission. And then from there, I could do whatever I want. But how do I get this token? Okay, so that's going to be the key, because still here, I'm a user inside of the cluster. I'm still not from the outside. So how do I extract this token? By using a curl from the internet. Okay. So the application is deployed. The application is accessible over curl to the internet or to any browser. Let me exit the pod. So if I go back to doing it from the internet, I need to extract the token. So to extract the token is use curl, because we're going to curl the application again. Right? We're just going to do this, but we're going to add a command. The command to extract the token. And to do that, it's you do just -a, quotation mark. So you don't have to remember this, but I remember it after a while. You just remember it. But you pass this this string here. So essentially, we'll do echo, and we'll do cat, and we'll cat the token, exactly like I did here. Cat. Oh, okay. So that's a bash command. So we'll do print bash -c for command, and var run service account /token, because we want to cat the token. right? And close the quotation mark. I do need to go back and add a quotation mark here because the command is to cat, right? Okay. And the space between that and the IP address of my application, the pod. And I got a token. And I'm doing this from the internet, right? Well, actually, I'm doing it from the command line on my cluster, but I could do this as well from any terminal anywhere. You know, you don't need to have any type of authentication to do it. This is leverage the bash vulnerability. Why? Because it's while setting a curl, that vulnerability is allowing to execute the cat command to the token. Okay. All right. So I got the token. So all I have to do is I could do this, pipe it into token file, and that's it. And then I can, so I have a token. So then I can use this token and use that as a bearer token for authorization purposes, authentication authorization to the cluster. Now, if I was, this is a service account tokens are JSON web tokens. So basically, if you go here to, this is the online decoder. As you can see here, it's saying, you know, this is a service account, namespace default, it gives you the namespace, it will give you the name of the token and so forth. So you can also do recon and get the information about your cluster. Okay, now, so all you have to do is set the token as an environment variable, and we'll call it token equal, and then the path slash token. Okay, because what I want to do is I want to do this. I want to have the token, the value of the token. So token. Okay. Oh, sorry. What I want to do. That's not that. That's what will give me the path. So what I want to do is cat. I want the content of it. Path and token. And if I was to do echo, then it gives me the value. So once I have this, all I have to do is, so if I curl again, the cluster, now if I'm trying to get access to the cluster, so what I'll do is I'll be curling the IP address of the cluster at the port of the API server, which is 6443. This is how you, for example, if you want to see all the pods configured in the cluster, look at every possible resource, this is how you do it. And you can manage the resource from there. So if I want to do that, then I'll just use this token for authorization purposes. So authorization, and the type of authorization is bearer, because it's a token, and then the token value, token, right? And then HTTPS, the cluster, which is, this is information that is available. If you have, if you do reconnaissance of, you use Nmap and you scan the IP address. 6443 is the default port for the API server. And you could then look at API, which is for core type resource, API group. Namespace, we know it's default, so that's part of the, it wasn't a token. And we can do pods. And it'll tell you, it'll do a get or a list. And this is all the pods that I have. So I will know, I only have 2 pods here, but it gives me all the information. And then if it's recon, then it's okay, the type of images that are used in the pod by just looking at the SHA signature. And then from that SHA signature, I can get all the CVEs that are applicable to this particular container image. And I can basically go through the CVEs and see which one I can use again for further exploiting the system. Right? So this is why this is so powerful. Now, why is it powerful? I mean, in this case, I have cluster admin privileges. So what I can do, I can not just list, I can actually do some damage, meaning is let's delete all the pods in your system. All I have to do is curl with the token that I have, and see I have pods now, right? And do an X and delete and pods. And what happened? Go get Kubernetes. My pods are getting terminated. It's a deployment, so it's okay. They get recreated, but in this case, they're getting terminated. All right, so you can do some damage, or you can basically, if you have a database pod, you can basically steal data and so forth. So As you can see, it's not that hard if you know what you're doing. I think the key here is to just to have a good understanding of the Kubernetes architecture, where the tokens are stored, or where the certificates are stored, um, and then use that to hijack and then or just publish applications on the web that users will get a hold of with service account tokens or that will allow with certain permissions that user downloads, and then you could trigger weaponize them from the internet. Okay. In this case, I use a CVE, which is just a cybersecurity vulnerability, but this could have been a malware as well. And how we do the malware is essentially, it's all about the pipeline to create your container image or the pipeline to deploy your application. So if in this pipeline, I'm building a container image with code that is on the repo, so I have a Jenkins file for the pipeline, a Docker file for the application. If you inject malicious files there, then this will be the pipeline will create the image, send it up to the registry, and then they'll be downloaded by the users. And you can publish an application installation manifest, and then you could so the key here: understand the Kubernetes architecture to harden your cluster, understand how a compromised pod can compromise your whole cluster. Whether it's with credentials, with tokens, with and so forth, and the need of shift left security to scan the code, scan container images, lock down your registries, and so forth. Okay, hope this was instructive. Just be careful not to do this in production, in your production environment. Run this in the lab, okay, please. I'm not responsible for anything you do. Now, just the last thing. If you want to know more and master Kubernetes, my course is on Udemy. It's actually a feature course now that they're featuring the course as part of the it's loading as part of the CKA. It's a feature course. It's hot and new, and you could take advantage of the coupon for May, which is May CKA 21. All right, this is a quick advertisement, and you have a good day.